Our universe is vast, almost beyond comprehension. It's filled with billions of galaxies, each teeming with stars and planets, forming a cosmic tapestry that stretches across the expanse of space. Yet, this might only be the tip of the iceberg, a mere fraction of a much grander reality. What if I told you that our universe might not be alone? That beyond the stars we see, there could be countless other universes. This is the mind-boggling concept of the multiverse. The idea that multiple universes exist, perhaps even an infinite number of them, each with its own unique properties. The multiverse is not just a science fiction trope, it's a serious scientific hypothesis that has emerged from cutting-edge theories in physics and cosmology. These theories, like string theory and quantum mechanics, suggest that our universe might be just one of many, each governed by different physical laws. They attempt to explain the origin, evolution, and fundamental nature of our universe, and in doing so, they open up the possibility of other universes. Imagine a universe where gravity is weaker or time flows differently. Each universe could have its own unique properties and laws of physics. Picture a reality where the fundamental forces of nature behave in ways we can't even imagine, creating worlds that are vastly different from our own. Picture a universe where you made different choices, leading to an entirely different life. The multiverse theory suggests that every possible outcome of every decision we make actually occurs in a separate universe. These are just glimpses into the potential of the multiverse. The idea challenges our understanding of reality and raises profound questions about our place in the grand scheme of existence. This concept challenges our understanding of reality and raises profound questions about our place in the grand scheme of existence. Are we just one of many versions of ourselves, living out different lives in different universes? Join me as we delve into the fascinating world of the multiverse, exploring the science behind it, its philosophical implications, and its presence in popular culture. We'll journey through theories that stretch the limits of our imagination and challenge the boundaries of our knowledge. Prepare to have your mind expanded as we journey through the infinite possibilities of the cosmos, exploring realms that may exist just beyond our reach. Our journey begins with cosmology, the study of the origin and evolution of the universe. This field seeks to understand the grandest scales of existence, from the tiniest particles to the vast expanse of galaxies. The prevailing theory for the origin of our universe is the Big Bang. This monumental event is thought to have occurred around 13.8 billion years ago, marking the beginning of time and space as we know it. This theory describes the universe starting from an extremely hot, dense state, and expanding over billions of years to its present size. As the universe expanded, it cooled, allowing matter to form and coalesce into stars, galaxies, and eventually, the complex structures we observe today. However, the Big Bang theory leaves some unanswered questions. For instance, what was the nature of the initial singularity, and what mechanisms drove the expansion? One such question is, what caused the universe to expand in the first place? This is a profound mystery that has puzzled scientists for decades. This is where the concept of inflation comes in. Inflation theory suggests a brief period of extremely rapid expansion in the universe's earliest moments, far faster than the expansion we observe today. Inflation theory proposes a period of exponential expansion in the universe's earliest moments. This rapid expansion would have smoothed out any initial irregularities and stretched spacetime, leading to the uniform and isotropic universe we observe today. This rapid expansion would have smoothed out any initial irregularities and stretched spacetime, leading to the universe we observe today. It also helps explain the large-scale structure of the cosmos and the distribution of galaxies. But inflation theory also predicts something remarkable. It might not have happened just once. Instead, inflation could be an ongoing process occurring in different regions of spacetime. Instead, inflation could be an eternal process, continuing in different regions of spacetime. This idea leads to the concept of a multiverse, where our universe is just one of many. This eternal inflation could give rise to a vast multiverse, with our universe being just one bubble in a cosmic sea of universes. Each of these bubble universes could have its own unique properties and physical laws. Each bubble universe would have its own unique properties, determined by the way inflation unfolded in that region. This means that the fundamental constants and physical laws could vary from one universe to another. Some universes might have different fundamental constants like the strength of gravity or the speed of light. These variations could lead to entirely different forms of matter and energy. Others might have different dimensions or even different laws of physics altogether. The possibilities are as vast and varied as the imagination can conceive, making the study of cosmology an endlessly fascinating endeavor. Our exploration of the multiverse now takes us into the realm of quantum mechanics, the theory governing the behavior of matter and energy at the atomic and subatomic levels. Quantum mechanics is known for its bizarre and counterintuitive predictions, and one of its most intriguing interpretations leads us down the path of multiple universes. This interpretation is called the Many Worlds Interpretation, MWI. Developed by physicist Hugh Everett III, MWI suggests that every time a quantum measurement is made, the universe splits into multiple branches. Each branch represents a different possible outcome of the measurement. For example, imagine a single radioactive atom that has a 50% chance of decaying in a given time. According to MWI, when we observe whether the atom has decayed or not, the universe splits into two. In one universe the atom decayed. In the other, it remained intact. This branching of the universe happens for every quantum measurement, leading to an unimaginably vast and constantly branching multiverse. Every possible outcome of every quantum event would exist in its own separate universe. Our journey through the multiverse now leads us to the fascinating and complex realm of string theory, a theoretical framework in physics that attempts to reconcile the seemingly incompatible worlds of quantum mechanics and general relativity, which is Einstein's groundbreaking theory of gravity. String theory proposes that the fundamental building blocks of the universe are not point-like particles, as traditionally thought, but rather tiny, vibrating strings. These minuscule strings vibrate at different frequencies, and these vibrations determine the properties of particles, such as their mass, charge, and even their spin. But string theory also predicts something even more profound and mind-bending: the existence of extra-spatial dimensions beyond the three we experience in our everyday lives. These additional dimensions are thought to be curled up or compactified at extremely small scales, making them invisible to us in our daily experiences. However, their geometry and configuration could have a profound impact on the fundamental nature of our universe, and even the possibility of other parallel universes. According to some versions of string theory, our universe might be a three-dimensional brain, a sort of membrane, floating in a higher dimensional space known as the bulk. Other brains could exist within this bulk, each representing a parallel universe with its own unique properties and laws of physics. Collisions between these brains could even provide an explanation for the Big Bang and the origin of our own universe, suggesting that our cosmos is just one of many in a vast, interconnected multiverse. Imagine for a moment that everything you know about reality is just one version of many. What if the universe you see is merely one layer in a vast, intricate tapestry of existence? This concept challenges our very understanding of what is real. It's not just science fiction anymore, it's a serious scientific proposition. So let's delve into what it means to redefine reality, and how these new ideas are reshaping our perception of the cosmos. Now, let's dive into the intriguing interplay between free will and determinism within the multiverse. Imagine, if you will, every choice you've ever made branching out into countless realities. Each decision, no matter how small, creates a new universe where different outcomes unfold. But does this mean we truly have free will, or are we merely following predetermined paths? It's a question that has puzzled philosophers and scientists alike for centuries. In this vast multiverse, are we the masters of our fate, or are we simply passengers on a preordained journey? The concept of the multiverse has captivated the imagination of storytellers for generations. From comic books to blockbuster movies, the idea of parallel worlds and alternate realities has become a staple in popular culture. Think about your favorite superhero flicks or science fiction novels. Many of them explore the possibilities of what could be, in a world just slightly different from our own. These stories, while fictional, often reflect our deepest curiosities and fears about the nature of existence and our place in the cosmos. Of course, the multiverse theory is not without its critics and ongoing debates. Some scientists argue that it is more of a philosophical construct than a scientifically testable hypothesis. They question whether we can ever gather empirical evidence to prove the existence of other universes. Others worry that the multiverse theory might undermine the very foundations of scientific inquiry, by making every possible outcome equally real. Despite these criticisms, the multiverse remains a hot topic in both scientific and philosophical circles, sparking lively discussions and further research. As we conclude our journey through the multiverse, it's clear that this concept opens up an ever-expanding frontier of exploration and discovery. Whether you're a scientist, a philosopher, or just a curious mind, the idea of multiple realities challenges us to think beyond the confines of our own universe. It invites us to ponder the infinite possibilities that lie beyond our current understanding. So, as we continue to push the boundaries of knowledge, who knows what new worlds we'll uncover in the vast, uncharted expanse of the multiverse? The adventure is just beginning.